is my extreme pleasure to have our guest speaker today, Anastasia Kuzminykh. Anastasia was a student of mine when I was a professor at Waterloo eons ago. She started as a master's student of mine, switched into the PhD program. I was a co-supervisor for a while and then became on her committee as I transitioned to Guelph. And it has been an extreme pleasure as her former supervisor to see her blossom into an amazing researcher and independent professor on her own. So I'm very excited to have her here. I will introduce a little bit of her background to you beyond that. So she's an assistant professor at the University of Toronto in the Faculty of Information with a cross appointment in the Department of Computer Science. She's the director of the Toronto Human AI Interaction Research School and the director of the Cookie Research Group, which we were just talking about, which is an awesome name, which stands for Communication, Organization of Knowledge, and Information Ecosystems. Her work is situated at the intersection of AI, agent design, explainable AI, AI safety, natural language processing, and conversational interface design. And many more. I will let you read her full bio, but I wanted to say, in terms of introducing this talk, that I saw her speak about her work, which she'll be expanding on today, at the Canadian Celebration of Women in Computing in Toronto that was held last fall. And I thought immediately that the rest of the CARE AI group had to hear what she's working on. It's so relevant to this group. She brings a really strong background in psychology and computer science. Her interdisciplinary approach to research really brings a new spin and perspective on human AI interaction and communication. So I'm extremely excited to hear her give this talk here and have the discussions that follow. So I'll hand it over to Anastasia. Welcome.
Thank you so much, Stacey, for so many warm and kind words. Welcome, everyone. My name is Anastasia Kuzminykh, and today I want to talk to you about the role of communication in human-AI collaboration. And I have given this talk with some minor variations several times this past year, with the main goal of discussing with different audiences the importance of this role, particularly given the growing communicative abilities of AI due to the rapid development of general purpose foundation models. And I believe that this communication is a key for unlocking true collaborative potential for our two types of intelligence, humans and AI. So although my PhD is in computer science, and for the last many years I'm an HCI and systems design researcher, and before that, as Stacey mentioned, I worked first in anthropology, then cognitive and neuropsychology, and I was always interested in communication processes. And with time, I became fascinated by this idea that humans and technical systems are communicative entities. And now at the University of Toronto, I lead the research group called COOKIE, which stands for Communication, Organization of Knowledge and Information Ecosystems. And in our work, the overarching goal is to develop an efficient collaborative communication between humans and AI. So the idea is that we have two powerful entities, a human and an AI system, and we want to put them together to make them collaborate so that they can optimize and complement each other. Sounds like a great idea. But this partnership, the success of this collaboration, is predicated upon building effective and efficient communication between users and AI systems, which involves the ability to understand each other and to present the information to each other effectively. And here is where the problem starts. So developing for such communication, as it turns out, is pretty tricky. And I usually start illustrating why it is tricky by inviting people to first think about the differences between classical interaction with machines and an act of actual communication. And here's how I like to schematically show the rough differences between those two. So in classical conventional interaction, we have two interacting entities, so let's say a human and a machine. And for a defined input from a human, let's say pressing a button, there is a defined outcome from the machine. This is the way how most classical user interfaces work in a nutshell that we all are used to. This interaction can be happening in many modalities, of course, pressing a button, shaking your phone, making a gesture, typing a command. And similarly, same goes for simple conversational user interfaces or CUIs. So straightforward conversational input, like, I don't know, Google Assistant Google tell me the weather, straightforward output, verbal, visual, or whatever other modality the system uses. But this is not yet communication per se. So how does communication differ? You can consider communication as a special type of interaction. And as a subtype, it again involves minimum two parties, let's say saying human and a machine. But now there is a perceived agency on the receiving side. And this agency is the capacity of entities, so in this case AI, to act independently, this perceived capacity to act independently and to make their own free choices. What does this agency change? Now we, as users, are trying to affect these independent choices on the perceiving side, on the AI side. And so as humans, we best know how to do it with other humans. So we start mindlessly anthropomorphize these systems. We start assigning its separate human-like qualities and traits to help us interpret and predict its understanding of our input, of what we're saying. And with classical human system interaction, when I press a button, I don't need to think whether the system would think that I am supportive or in a rush or happy. It would expect the same outcome every time. I would expect the same outcome every time. Within communication, because of this perceived agency on the receiving side, I can expect variations in interpretation of my actions. So now for a given input, the output might significantly vary. So now within communication, our user, the entity on the left, would start changing different properties of their input, trying to adapt, trying to affect this interpretation. And the encoded meaning of this input suddenly becomes contextually dependent. So as a user, I'm going to be giving input in one way in one context and in a different way in a different context. And of course, we want this process to be bidirectional, as most cases of true communication. So the system's output should also be synthesized corresponding, depending on a contextual meaning of the user's input. Of course, communication might be happening in many different modalities. However, conversation, so our verbal language, is one of the most intuitive and common modes of communication. So at least at this stage of our academic development, our community predominantly focuses on language, at least as input modality in human AI communication. So why is this difference between interaction and communication is particularly important to the development of human AI collaboration? Well, because it allows us to finally start shifting from purely using machines as a tool to working together with them towards a common goal. So from pure interaction, from telling the system what it needs to do, to human system communication, to working together with it on a common task. For example, instead of telling the system to label a particular piece of data as X, I would tell it something like, we need to figure out the best label for this piece of data. And this working together with the system towards a common goal is basically what true collaboration is in essence. So while there is still a lot to learn on how to build AI systems so that this collaboration, this partnership between humans and AI can actually work and can work in our favor and to its true potential, it's rather clear that the success of collaboration is predicated upon first building systems that are can produce what we want them to produce. So they need to be reliable. And what's particularly important, we need to be able to appropriately trust their outcomes. And appropriately here means that we trust the system according to its performance and not over-trust or under-trust, over-rely or under-rely on the system. Second, the systems should be communicative. So we need to be able to understand what they produce, and they need to be able to understand what we want from them. And finally, they need to be useful in a broad sense. So we as humans should be able to effectively incorporate what they produce. And ideally, we want to avoid any harmful, unwanted societal consequences from this collaboration. So what is the role of human AI communication in ensuring all of it for the systems? First, since communication becomes contextually defined, its interpretation is different in different contexts. And it means that the system should be able to produce outcomes that are reliably relevant to these different contexts. For example, if I ask the system to write a piece of text, like a passage, the system needs to understand that writing a passage for a school essay and writing a passage for a social media post requires different styles, and it should produce different outcomes accordingly. And this is achieved, for example, through the algorithmic design of systems, of models, and different approaches to their training. Second, given that the human input becomes contextually dependent and varies in many of its properties, such as, let's say, the structure of user prompts, different nuances in vocabulary, there are a lot of efforts, a lot of work directed towards decoding these variations in human input. So that we need for the system to be able to properly follow users' prompts and interpret their communicative input. And that, of course, contributes to our ability to develop systems that understand us. The mechanisms that define these variations in users' input and what the human user is actually saying depend on users' mental models, right? So the user's understanding of the system and how the system works. And knowing these dependencies between users' mental models and how they formulate their input is needed, again, to support appropriate decoding of input and understand what exactly the user means. And so these mental models, this understanding of the system is influenced, of course, by a myriad of factors, and it would be different for different user groups. So let's say mental models of domain experts would significantly differ from those of naive users, and would also depend on different social and cultural aspects in the background of users. And also they're affected by common knowledge about AI systems, different societal perceptions that often come from public media. That's why we direct a lot of efforts in studying these public perceptions, different predispositions towards the system. And of course, all of that affects our trust dynamics and our idea of how reliable the system is. Because no matter how well the system actually performs, if we are predispositioned to under-rely, not to trust it, its actual performance wouldn't matter, right? And the other way around. And of course, mental models and these perceptions are heavily affected during the human system communication itself. And here, these users' perceptions are affected by systems out. For example, how the system speaks or what it shows to the user. And correspondingly, exploring these relationships informs the synthesis of the system's output. And again, there are so many nuances here, from the sentence structure to the speed to using different types of addressing and referring to objects in the discussion, and so on. So understanding how to synthesize and how to format the system's output contributes both to the system's perceived reliability and to its communicativeness, so how it talks to us as users. And finally, all these processes, of course, influence different aspects of task performance and task outcomes, because that's why we actually develop this collaboration, design this collaboration. And of course, unsurprisingly, understanding how it happens is needed to develop useful systems so that we can effectively use what AI produces while be mindful, considering the corresponding societal consequences. And in our group, we explore all these parts. And as you can imagine, there is quite a lot to cover here. So today, I'll give you a brief dive into the role and place of communication in collaboration, in human AI collaboration, by first talking about some of our work on how the architecture of the system's output, what and how system communicates to us, affects users' perceptions. Then I'll talk about what we learn on the ways users formulate their communicative input to the AI system. And finally, I'll give some examples of our work on the effects of communication on these human AI collaborative tasks. So in exploring how the architecture of the system's communicative output affects users' perceptions, in my group, we mostly focus on verbal output, both in text and in voice. For example, we're looking at the opportunities to use speech variations as trust calibration techniques for voice-enabled prediction models. Or, for example, we explore the effects of the structure of verbal AI explanations on the interpretation of information. So perception of its trustworthiness and reliability, fairness of, let's say, financial model decisions. But in the last few years, to support human AI communication, more and more systems now make use of entity-based interfaces, or these artificial agents. So I would like to start here with the study that actually started this whole journey for my group, which was a study on comparative analysis of anthropomorphized perceptions of commonly used agents. So intuitively, we all know that not all the agents are seen the same. But our understanding of the underlying patterns of these perceptions, of how we see these agents, is rather immature. So what we did know from before, mostly about anthropomorphization, mostly from robotics, is that researchers differentiate between design of agents' behaviors, such as, let's say, emotional responsiveness or personality of an agent, and so on, and design of agents' physical or visual aspects, let's say facial and body expressions or voice characteristics. So I like to give this example that Roomba vacuum has only behavioral anthropomorphic traits based on how it moves. And wax sculptures would have only visual ones. They don't move, it's only the way how they look. So by design, voice assistants are capable of displaying mainly behavioral anthropomorphic aspects. But what of the, like, which aspects there matter to users, and is there any structure in what matters, was pretty unclear. So we hypothesized that if there is any structure, then these perceptions will be consistently different for different agents. And we also hypothesized that the way people perceive the personality and behavior of these agents would affect how they visualize them. So how users think the agent would look like if they were humans, especially since agent answers might often include some visual references, like the old series, I'd blush if I could. So then, if there are consistent patterns in these behavioral perceptions, we, of course, can also expect consistent differences in visualizations of these agents. And all these questions we could explore only through comparison. So we took 3 agents, Alexa, Google Assistant, and Siri. And we first asked people to interact with them because we wanted to actually allow for this comparison in the moment. We conducted interviews asking people what each of these agents would look like if they were humans, what would be their specific characteristics. And finally, we asked people to create an approximate visual representation using that avatar builder of Alexa, Google Assistant, and Siri. So what did we find? The main highlight was about the perception of this agent's character, about the behavioral perceptions, was that those were indeed structured, and they were structured according to these 5 categories: approachability, sentiment towards the user, professionalism, intelligence, and individuality. And more than that, they were indeed different for different agents. And so each of these 5 themes was represented through a comparative scale. So let's say the theme of approachability reflects an assessment of how emotionally distant or approachable an agent was seen. Let's say the distance end here includes example, like agent being seen as closed off or snarky. And this often would be in contrast with users' willingness to engage in this closer relationship. So for example, a very one-sided relationship, like they don't want to talk to me, like here's your answer and go away. And the approachable side of the scale was the agent seen as emotionally warm, friendly, for example, being welcoming, outgoing, chill, feeling more like a friend. Another thing here, the agent perceived sentiment towards a user is defined through this dichotomy of genuine versus disingenuous agents' attitude. So how trustworthy and how focused how focused on the user they're seen. And the genuine aspect here would be descriptions of an agent such as benevolent, caring, they're coming from a good place, really trying to help you. And opposing that, this disingenuous side, was the perception of an agent as inconsiderate, maybe cunning. For example, descriptions such as sly, pretending, or my favorite about Siri, uses her sus as a defense mechanism. One more example here, the theme of agent's individuality showed the participants' perception of how much character an agent is displaying. So the dichotomy here is between neutral and defined individuality. And the neutral aspect was this perception of an agent as highlighting the agent's ordinary, so just some random kid trying to blend in. And the defined individuality was different for different agents. And so let's say for Google, it was this warmer but nerdy chill. And for Alexa, she had a glowing personality. So the behavioral perceptions are both structured along these 5 dimensions and are different for different agents. But what about the visualized perceptions? So we first composed users' visualizations into collages and also created a cumulative visualizations of each agent. And as you can see, the outcomes are already quite illustrative on the differences. But we also looked at the verbal descriptions of these avatars and identified, again, different themes in agents' appearances. So some examples here would be, let's say, the agent's age. There was a trend that Alexa is generally perceived older and Siri is seen younger. There also were specifics of facial expressions that often would reflect the perceived approachability of an agent, which kind of interestingly shows the difference between these agents. And let's say Google was perceived as, Google seems stressed, they got a lot of stuff, Alexa is just maybe a little bit smiling, and Siri would be smiling a lot and has a lot of energy. And another fun example from the study is the clothing style was heavily dependent on the personality of an agent. And so for Siri, the clothing was revolving around this highlighted femininity and daring personality. So she would be wearing heels, mini skirts, pleated skirts. And Google clothes were associated mainly with stereotypically awkward looks. So let's say wearing leotards or wearing jeans and t-shirts that do not fit them well. And Alexa clothes kind of reflected her cozy nature. So like pullovers, big sweaters, or mom jeans, or running shoes. So with that, both behavioral and visual perceptions of conversational agents seem to have this consistent structure. And now we wanted to see what design elements affect each of these perceptions. And we identified 3 major categories. So first was the category of provided information, including the amount of information, the level of details. Let's say they give me more information, so it seems like they care about you understanding what they're saying. Second was the designed interaction style of an agent, so such as, let's say, responsiveness to prompts or prompting users back, and the tendency to use jokes. And the third category was the agent's voice characteristics, like more enthusiastic, like there is more inflection in her voice, sounds a bit more fun. And all of these results were shown to have different impacts on behavioral dimensions and visualized perceptions of an agent. So the main takeaway from this study was that, first of all, people produce extremely rich and socially meaningful interpretations of the agent's actions, which includes users' extreme tendency for displaying biases and social stereotypes. So their anthropomorphized conceptions are very socially and emotionally charged. But the good news was that it seemed like there was a consistent dependency on particular elements of the system, which kind of gives us a stable gateway to these perceptions as we develop voice-based agents. And so now, as we found that there are some effects and dependencies there, now we wanted to dive deeper into that and have a more comprehensive understanding of these dependencies. So here I'll briefly talk about another study we did. This is one of our recently published projects done in collaboration with Yang Hui Kim from Neighbor AI Lab. And so again, we knew that users, when they interact with agents, they form different perceptions of an agent, like intelligent, likable. And because agents use natural language, one of the key factors shaping these perceptions is the conversation architecture. So we wanted to know how to develop this agent speech to affect these perceptions, to control them. But there was no systematic understanding of how this conversation architecture affects different perceptions. So how do I need to synthesize the agent speech if I want it to be perceived in one or another way? So with that, we wanted to understand first, what are the perceptions of agents that are affected by conversation? Then we wanted to see what elements of conversation affect these perceptions. And finally, what is known about the specifics of the relationship between the two. And because there were quite a lot of studies looking at different aspects of this effect, we decided to synthesize what is known on the effects of this conversation architecture elements on the perceptions. Now, we did a systematic literature review of works published from 2010 to 2022, and here is what we found. So to answer the first research question, what are the perceptions of agents that are affected by conversation architecture? We found 4 categories of these user perceptions. The first one was the category assessing the overall interaction quality between user and an agent, including such aspects as usability, engagement, so how that captures users' emotional reactions to interactions with an agent, and user satisfaction. Second was perception of agent's ability, which was the perceived capabilities of an agent with aspects of intelligence and aspects of competence, so kind of intelligence put into practice, and credibility, so how truthful the agent is perceived, how benevolent they're seen. Then perceptions of sociability with an agent, which was referring to the emotional connection that users have with an agent, including the tone of conversation, social presence, and the sense of intimacy. And finally, perception of agents' humanness, so how human-like they are in general, and personality traits. For our second research question, what elements of conversation architecture are affecting these perceptions? And we also found 4 categories. The first one was the dialogue strategy, which included the use of social dialogue, showing initiative in the dialogue, and the response delay on the agent side. The second category was the content effectiveness, which included the use of effective language and humor. Then the category of content style, which referred to something that goes aside of the meaning and focuses on the format of the message. So how formal it is, how aligned it is, like how well it matches the utterances to the user's ones, and how elaborative the sentences are, how complex they are, and what's their length. And finally, the category of speech format, which was the non-verbal component. So it could be use of disfluences, prosody, like pitch and intonation, for voice-based agents, or text formatting for text-based agents. So now that we understood more about what perceptions of agents are affected by conversation architecture and what elements of conversation architecture affect these perceptions, we wanted to know how they are connected. So what is known on the specifics of those relationships. And we found that, you can find more details in the paper, but we found that the perception of CA's abilities, such as intelligence, competence, credibility, have been explored the least in relation to speech variations, while perceptions of interactions with agents, such as usability, engagement, satisfaction, have been explored the most. And on one hand, it kind of makes sense because these general perceptions, such as engagement and satisfaction, are probably somewhat easier to explore. But at the same time, the complex perceptions, such as credibility of an agent, are arguably deserve much more attention from our side. Now, these were some examples of how systems output structure affects users' perceptions, focusing on perception of artificial agents. And I find this work, the work on these perceptions, particularly topical today, because while some early agents that we explored, like Siri, Google Assistant, Alexa, they relied on narrow models. Now we see the rise of these general purpose foundation models like Gemini, GPT-4, which opens new horizons to the agent's abilities, like information generation, strategizing. And so we really need to push on understanding how to design the communication with these agents, and we need to do it relatively soon. So now let's move to the second part, research on how users formulate their communicative input to the AI systems. And right now we're mostly focusing on variations in conversational prompts and prompt engineering for generative AI systems. And we also look at the conversation data exploration. So for example, we look at the cross-modality prompt alignment in AI-assisted art generation, or conversational exploration of documents. And the idea is that, of course, overall, people try to vary their prompts using different strategies depending on what they want to get from the system. So for example, in this project on the slide right now, we investigated the prompts used for AI art generation and the associated biases. So we analyzed what types of biases people are discussing in relation to the prompts that they give to these art generating systems. And we found that people mostly discuss gender and racial bias, and alongside with economical and political biases. And so we wanted to see what aspects of their prompts they associate these biases with. And so we found that first, particularly sexist outcomes, so gender-biased outcomes, were seen in association with certain job types in prompts, particularly with assertive words, like let's say, including search terms like CEO, exclusively generates images of white-passing man in business suits. We also found that people associate biases with the use of words such as, let's say, nurse or personal assistant, that prompt systems to create images of predominantly women and female characters. And lastly, there's some words that have kind of harmful stereotypes associated with them. So one example being that mentioning womanhood would often return suggestive images. And so in this study, I know I talk about it very briefly, but I refer you to the workshop paper as well. So in this study, we looked at how people adapt their communication based on the system's response. Of course, as designers, we should also focus on how the system should adapt their behavior based on users' input, because that's our ultimate goal, right? So for this, we need to learn to better understand what people actually mean and what they want from the system when they give their prompt. So we need to learn to better interpret the intention behind the prompt. And I want to give you here an example of Nazar Panachevny's work, where he wanted to develop a system that would collaborate with users on developing charts. And he wanted to use natural language interface for the system, but for the similar current systems right now, they tend to prioritize text over voice as their input. And he wanted to use voice interfaces because of the freedom of expression that they provide, and because they're seen as more accessible. So the system would need to be able to recognize and interpret human input. And so Nazar first examined, through user study, the structure of human voice descriptions for chart creation. And then he compared it to equivalent text descriptions. And he found that voice descriptions have a variety of command formats and different element characteristics, complex linguistic features. And the text input would usually include only some of these elements. You can see them in red on the slide. And voice instructions would have, let's say, iterative commands to perform tasks for each element. They would refer to chart elements created earlier. They would ask system for advice. They would correct previously described elements, and so on. So Nazar's work showed that the voice authoring systems voice authoring input is much more complicated, and thus the systems with voice interfaces should be trained on specialized voice descriptions data sets. And it's not enough to just use speech-to-text translation and rely on text-trained systems. And this work was just accepted for Kyle breaking work for this year. And in a similar note with Anshuta Kulkarni, we're exploring the differences between how people express different social dynamics, such as demonstrating engagement or supporting group cohesion, or applying social protocols, let's say, in conversations with agents versus in conversations with humans. And knowing these differences, this paper is under submission right now, but knowing these differences would allow us to better design this intent recognition, right? So we would be able to better interpret input when people communicate with agents. It also shows that the correct recognition and interpretation would require different approaches to training the models. So it seems like we can't just take human-human conversation and use it for training for human AI, for recognizing these processes in human AI communication. Finally, the quality of collaboration, of course, depends on how the systems are being incorporated into the task space. And again, I chose some projects here to showcase to you, including projects on the, let's say, perceived ownership of human AI co-creations, or on the workers' marginalized perceptions that is happening if these collaborations are not properly structured. And I would like to start here with the project by Sharon Ferguson and Paula Aoyagi, both PhD students, on how people use AI input in cases that require argumentation for one or another decision. So here we explored human AI collaborative decision-making, specifically focusing on ambiguous scenarios that are not based on ground truth. So let's say in diagnostics, there is ground truth. The person either has particular, let's say, disease or doesn't have. In other cases, let's say as hiring decisions or judiciary decisions, there is no ground truth per se, and it is depending on these contextual decisions. This also became particularly important in context of content moderation, because most of the, let's say, sexist moderation is currently based on the use of explicit language or recognizing explicit language, while things like subtle sexism are much more hidden, and the interpretation is very context dependent as well. So the moderation decision is typically left to a human, and AI support in this case could be used to surface new perspectives while making these decisions. And you will notice that the slides are of slightly different style. That's because I actually borrowed them from one of Sharon's and Paula's presentations. So in this study, we first identified subtle sexism scenarios that naturally occurred. So they were posted on discussion sites online. We then chose 10 of these scenarios and prompted the GPT model with them, asking the model whether it thinks that the scenario is sexist or not, and asking to explain why the model thinks so. And that resulted in intent text explanations produced by the model. And then we ran a user study. So we first asked participants to read a potentially sexist scenario, and then we asked whether the scenario is sexist or not and why. So they needed to explain their decision in writing. Then we we showed them the text explanation from the model, from GPT, for the same scenario, and told them that that was model generated. And finally, participants were asked to provide their final assessment to the scenario and an explanation of it. So we found first that GPT-generated text impacted the language that people used in their explanations. And participants would start borrowing terms directly from the model's explanation. For example, on the top here, you can see the initial human-generated explanation. Then participants saw this piece of text from explanation from GPT. This is kind of thinking that leads to common stereotypes about women. And in the final explanation written by the participant, you will see the word stereotype that is brought up, but the rest of explanation remained unchanged. In other instances, we noticed that human participants may have been kind of trying to match the level of detail provided in GPT explanation for their final one. So for example, this initial explanation was pretty short on detail, but the AI explanation was much more detailed and elaborated. So in response, the participant added details, even though they did not agree with what the model was saying, right? So they did not change their assessment of the scenario, but they changed the level of detail. And lastly, we found that in some instances, the human participants changed their argumentative direction for the final explanation. So this change typically would happen if participants were kind of on the fence at the beginning. So let's say here the initial explanation stated, I'm a little torn with this scenario. Then the participants saw the GPT explanation, which strongly thought that it was not sexist. And in the final explanation, our participant agrees with the model, changing their stance from it depends to it is not sexist. There are actually some other changes that we explored further in this project, but again, that paper is currently under revision, so I hopefully will be able to tell you more about this project soon. So the study provided this first early empirical evidence on the influence of LLM-produced collaborative input on human rationale in these subjective scenarios, in ambiguous cases. And unlike objective decision-making, subjective and personal decisions benefit from new information and new perspectives. So AI, let's say LLM in this case, could expose different patterns and insights and new viewpoints that humans might have missed. And while we found that people do adapt their language after seeing explanations and try to match details, we didn't see any evidence of people blindly following the stance presented by the GPT outcome, which is the most common concern in discussion of this over-reliance and trust calibration with this type of collaboration. And so in this paper, we kind of looked at the usefulness of AI assistance, but it also can sometimes bring some trouble. And in my last several minutes, I'm gonna quickly cover the project that kind of demonstrated some of the ethical issues hindering the usefulness of this communication, if not designed properly. So in this project, we examined the use of conversational agents in the financial sector. We examined 34 chatbots in banking and financial industry and identified 3 broad areas where these agents exhibit or reinforce societal biases due to the due to the lacks of some design decisions. And that led to marginalization of some groups of financial workers, including the assumption of low value work, concealing human labor, and reinforcing gender stereotypes. So first, the assumption that transactional work performed by customer services is repetitive and can be automated was kind of reinforced by the way how the bots were designed. So by automating more of their tasks, it introduces kind of this self-reinforcing cycle that confirms the societal perception of the value put into this work. Second, a lot of these chatbots were concealing human labor behind the machines. So many companies would choose to have a human agent jump in and handle inquiries that the agent was not capable of processing or answering properly. And if these agents are not designed correctly, customers may not have been able to distinguish between talking to a worker versus talking to a machine, right? So it's kind of concealing the human work behind. And lastly, these conversational agents were reinforcing a lot of stereotypes, such as, let's say, typically choosing female names for these agents, like Erica from Bank of America, as well as some choosing to use a female representation avatar. And these choices have some danger of perpetrating harmful stereotypes, such as, let's say, attributing some subservient attitudes to the female workers in the customer service areas. Okay, so to summarize, today I tried to convince you of the importance of collaborative communication between humans and AI. And I did it first by talking about the effects of the architecture of the system's output on users' perceptions of the system. And I focused on several projects related specifically to the perception of conversational agents and artificial agents. Then I talked about how users formulate their communicative input to AI systems and how it's important for us to understand, why it's important for us to understand and to be able to correctly recognize users' contextually dependent intent. Here I talked about systems, about work on the biases in depending on prompts and the differences between modalities of prompts. And finally, I talked about the usefulness of systems, the effects of communication on the usefulness of systems, on the example of the study on human AI collaborative decision-making in ambiguous scenarios and workers' marginalization in the financial sector. And I'm going to, at the end, to again bring this slide with our sponsors and all the amazing students who drive the research I presented today, and actually many more exciting projects. So I invite you to look at our work in more detail, because of course, without the students, none of this work would be possible. And with that, I would be happy to take your questions. Thank you for your attention.
That's